what is the effect of output of solar panel when the inclination angle of solar panel is changes. For checking the effect of output, first we are going to measure the open circuit voltage as well as short circuit current when the solar panel in the 90 degree. After that we are going to change the angle to 30 degree, 60 degree, then 0 degree. Then we will measure the corresponding output voltage, that is open circuit voltage, then short circuit current. So, from the reading we can find out when the inclination changes whether short circuit current increases or decreases. Similarly, the open circuit voltage increases or decreases. We are going to check. First, now the solar panel is 90 degree. Take the reading of short circuit current. What is the reading? 0.75. It is a short circuit current. Now you remove the short circuit, measure the voltage. Measure the open circuit voltage when the panel is in the 90 degree. When the panel is 90 degree. Yes, it is 19.52 voltage. It is 19.52 voltage. So, when the solar panel at the 90 degree of inclination, we are getting almost 0.75 amps at a short circuit current. The open circuit voltage is 19.5. Now, we are going to change the inclination angle from 90 to 60 degree. How much? So, now is here 60 degree. Now, you measure the short circuit current. What is a short circuit current? So, it is 0.95 amps. This is short circuit current when the solar panel is the 60 degree. Now, we measure the open circuit voltage. How much? 19.7 volt. 19.7 volt. Okay. Again, we are going to change the inclination angle to 30 degree. Yes. Now, you measure the current. Now, the short circuit current is same 0.95 amps. Check the voltage. Speed. So, it is 19.8. It is 19.8 voltage. Now, we are going to put the angle at the horizontal position, that is a 0 tilting angle. Now, we are going to measure the short circuit current and open circuit voltage. Measure the short circuit current. So, it is around 0.5 amps. It is 0.5 amps. Measure the open circuit voltage. (19.3 volt). 19.3 volt. So, from that we concluded when the solar panel is perpendicular to the sunlight, it will get higher short circuit current and open circuit voltage. When the inclination angle changes from the perpendicular to some other angle, we will get the reduced voltage as well as reduced current. We have to check the specification of various solar panel. From its nameplate details, then only we will get the idea which panel having the more efficiency or which panel is made by polycrystalline, monocrystalline or thin film. Then which panel have the maximum system voltage or open circuit voltage, which panel have the higher short circuit current, that we can see from the nameplate details. For that we have to compare the various panels. For example, here we have the A marked panel. This is the A marked panel, energy. It is 80 watts. This maximum power, that is a peak power, is 80 watts. The maximum voltage at maximum power is 18.7. The maximum current at maximum power is 4.2. The open circuit voltage is 22.57. Like that, we have to take the reading. Please note down the reading of the individual solar panel by peak power, short circuit current, open circuit voltage and voltage at maximum power, current at maximum power. Then what is the fire class, what is the application class, everything you have to note down one by one. This is the first panel. This is second panel. This is a Havells panel. It is a very small panel. It is generally used for lantern lighting system. It is a 3 watts panel. Here also you can find out the what is the open circuit voltage, short circuit voltage, what is the peak power, then what is the fire class, application class, everything will be there. You have to note down and you have to tabulate in a tabular column by mentioning the manufacturing name, watts of the solar panel, then short circuit and open circuit voltage. Like that you have to complete the solar panel available with us. There are 4 type of panel available in this roof. One is a 80 watts panel and one is a 30 watts panel. One more is 540 watts panel is there. In 100 kilowatts power plant, we have one more 540 watts. That is a SOA solar panel. You have to take the reading of all. This is our third exercise of day 3. Here we are going to connect the solar panel in series. Then we are going to measure the open circuit voltage and short circuit voltage. Already we are knowing when the solar panels are connected in series, the system voltage, the output voltage will increase. How to connect the solar panel in series? This is the positive and negative terminals of first solar panel. This is the positive and negative of next solar panels. So, how to connect the solar panel in series? We have to connect the negative of first solar panel into positive of second solar panel. Then it is connected in series. Now we are using the positive of first solar panel and the negative of second solar panel as a output terminal. This is a output positive terminal. This is output negative terminal. Now we are going to measure the short circuit current of series connections. So we have to connect the positive and negative terminal with the ammeters. We are going to measure the current, short circuit current. So this is a series connection. We can measure the short circuit current. To measure the open circuit voltage, we just disconnect the short circuits and measure the voltage using multimeters. Just measure the voltage using multimeters. Yes, how much voltage is coming? Maybe around 96 voltage, This is a series connection. The series connection of solar panel, we are checking only 2 parameters. One is a short circuit current. It is around 13 amps. Then open circuit voltage, it is around 90 volts. We are going to connect the solar panels in parallel and going to measure the open circuit voltage and short circuit current of the parallel combinations. So when you are connecting the solar panel in parallel, the voltage will be same. In parallel circuit, voltage will be same, but current will be increased 2 times. When we are connecting 2 panels, the current will be increased by 2 times. To connect the solar panel in parallel, we have to connect the positive terminal of solar panel 1 with the positive terminal of solar panel 2. Similarly, the negative terminal of solar panel 1 with the negative terminal of solar panel 2. Then we have to take the common positive and the negative solar terminals as an output. So this is the output of the common positive and negative terminal of parallel connections. Now we are going to measure the short circuit current and open circuit voltage of the parallel combination. To measure the short circuit current, we are just going to connect the positive and negative terminals with the ammeters. So we are going to connect the positive and negative terminal of the ammeters. Yes, first I will connect, then you connect. Yes, it is around now 4 amps is coming. Because of both the parallels are connected in parallel, so current is increased by 2 times. So we can measure the open circuit voltage. Just remove the short circuit connections, then use the multimeters to measure the open circuit voltage. Connect the positive terminals of the multimeter with the output positive terminal, the negative terminal of multimeter with the output negative terminal. This voltage is around 44 voltage. Because in parallel connections, voltage will be same. So we are getting the same voltage of 44 voltage as a open circuit voltage. Dear student, today our third day practical is over. Today we have seen 4 practicals. First one is what is the effect of output of solar panel when the inclination angle of solar panel changes. Second one is we note down the specification of various solar panel and compare the specification. Third practical is we are connecting two solar panel in series and measuring the open circuit voltage and short circuit current. Fourth, finally, we have connected the two solar panel in parallel and measure the open circuit voltage and short circuit current. Then measure the what is the effect of series and parallel combinations. So today our third day practical is over. Thank you.